Welcome, this is Professor Ridge. Today's lesson 1.5, Factoring Polynomials. Let's get started with the first learning objective, factor the greatest common factor of a polynomial. Factoring the greatest common factor of a polynomial. So we start with the definition of a greatest common factor for a polynomial. Is the largest polynomial that divides evenly into the polynomial. Okay, let me give you a real simple example before I put down what the book has. So let's say I had something like 6x to the third plus, let's make it simple, 2x. Okay, so the greatest common factor that divides evenly into the polynomial, what you're going to look for is a monomial or bigger, but typically start with the monomial. What divides out of both of these terms? So think of, so you kind of break it down. You could see that 2 divides in both 2 and 6, and x divides in both of those. So that would be the GCF. And you can see if I were to divide that out, 6 divided by 2 is 3. X cubed divided by x is, actually here's the way I like to show it. So basically when I divide this out, 6x cubed over 2x and 2x over 2x, you can see there's not going to be any fractions left here. It's going to divide evenly. So 6 divided by 2 is 3. X cubed divided by x is x squared. 2 divided by 2 is 1. X divided by x is 1. So you just get 1. Okay? And then 2x would have been the GCF for the original polynomial. And if I factor it out, this is the process. And typically we don't show that step in the middle. Okay, so here's the procedure outlined in the book. Your first step is you're going to identify the GCF of the coefficients, kind of like I did with that previous example. Identify the GCF of the variables. So kind of think of it as 2 stages. Do the numbers, then the variables. Combine to find the GCF of the expression. Determine what the GCF needs to be multiplied by to obtain each term in the expression. Write the factored expression as the product of the GCF and the sum of the terms we need to multiply. Okay, so again, we're going to look at just the numbers. So what divides in all 3 of these numbers? 6, 45, 21. So if you're not really good at finding GCFs, you can look at the factored form. So 45 is 9 times 5, 9 is 3 times 3, and 21 is 3 times 7. So what factor is common to all of them? So you can see they all have a 3 that's in common. Okay, so the GCF for the numbers is just going to be 3. 3 would divide in all of them, and then what's left, right? So 6 is 2 times 3, so if I factor out a 3, I'm going to be left with the 2. 45 divided by 3 is the 15, 3 times 5. So if I factor the 3 out, 15's left. So this is another nice benefit of looking at factors. 21 is 3 times 7. If I factor out the 3, I'm left with the 7. Or you can just say 21 divided by 3 is 7. Okay? Now we're going to do the same thing with the variables, x cubed. So again, you can think of x cubed, I'm not going to write it, but it's x times x times x. Y cubed. Ooh, why can I not write the cube there? There we go. And then we have x squared, y squared, and then x, y. So when you look at looking at the variables, okay, so do variable by variable. So look at x's. They all contain an x. So the way, again, think of x cubed as x, 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 x squared is x, x. So a couple ways you can do this. So you can see they all have an x in common. So the GCF would be, there's just one x in common. The other way to do it is they all have an x and then take the lowest power for x, so x to the first, right? So either way. And then y cubed, similar, right? You have 3y's, 2y's, and 1y. So you take the lowest power, if you're looking at powers, they have 1y in common. And then when I divide it out, you're taking 1x and 1y out of each of these. So what's going to be our answer here? Okay, so the GCF for the combined thing is going to be 3xy. So we're here at step 3. So 3xy. So you write it down. So that's your GCF. And we're factoring it out. So we put a parenthesis. Now you're going to divide the 3xy out of each of the terms. So if we have, again, there's a couple ways you can do this. This is the way I think of it. I don't ever write the step down. It's just what I'm going to do in my head. I'm going to divide by that GCF. 45x squared y squared over 3xy. And then 21xy over 3xy. So then that's going to get me the GCF, 3xy. Now again, I wouldn't write this down. This is what I do in my head. So I'm going to do 6 divided by 3 is 2. X cubed divided by x is x squared. X cubed divided, y cubed divided by y is y squared. And then I do that for each term. 45 divided by 3 is 15. X squared divided by x is x. Y squared divided by y is y. And then the last term, 21 divided by 3 is 7. The x's cancel, the y's cancel, so I'm just left with 7. Okay, again, if you think of it this way, you're factoring out the 3, and what's left? You're left with the 2, you're left with the 15, you're left with the 7, and then looking at the variables, if you're taking 1x, you're left with x squared for the first one, x for the second one, and there's no x's left because we've taken all of them. And then do the same thing for the y. Okay, so I don't care which way you do it. Whatever makes the most sense for you. As long as you can get to this answer, you're good. Okay, factoring a trinomial is our next learning objective. Okay, factoring a trinomial with leading coefficient 1. A trinomial of the form x squared plus bx plus c can be written in the factored form as x plus p times x plus q, where p times q is equal to c, and p plus q is equal to b. So, I know a lot of high school students around here use this X method, or sometimes called the diamond method, because originally it was you made a diamond, but then that's, takes more time to write. So you're going to put this number at the top, this number at the bottom, so B and C, and you want to find two numbers that multiply to C, so that's where it goes here. So P times Q would be C, and then they add to B. P plus Q is added to B, and then that's where you get your X plus P, X plus Q. So I do this, my method's a little bit different. It's basically the same thought process, so if you're good at this method or whatever method you use, that's fine. Again, this is supposed to be review. But let's look at example 2. I'm just going to write it down. So example 2 is factor x squared plus 2x minus 15. And I'm going to show you the way I do it. I like to take out, I want to take out the signs. I'm going to put plus or minus C, and then this would be plus or minus Q. This sign tells us if you're going to add or subtract. So in this case it's minus, so I'm going to subtract. So I want factors of 15, so this is the way I kind of do it. So I want factors of 15 that subtract to 2. So find factors, so I call them factor pairs, two whole numbers that add or subtract to 15. I'll just write factors of 15 that, in this case, it subtracts to 2. So if I do all my factor pairs, now if you're not good at finding factors, the first thing that would pop in my head would be 5 and 3, and that would work. But let's say I don't, so I write the 15, and I start with 1. Get out a calculator if you don't know. 15 divided by 1 is 15. Then go 2. 15 divided by 2 is a decimal number. We want whole numbers. 15 divided by 3 is 5. And then you're going to keep going until you get to the square root of 15. So if you did the square root of 15, all right, so that is about 3.87. And basically, so you can stop at 3. You just chop off the decimal part. You don't even round it. So this is all the what I call factor pairs, two whole numbers that multiply to 15. And then if this is plus, you want to find factors that add. So 1 plus 15 would be 16. 3 plus 5 would be 8. If this is minus, you want to subtract these. Right? So the difference. We're going to do the bigger one minus the smaller one. Okay, so it will be 15 minus 1 is 14. 5 minus 3 is 2. So we want factors of 15 that subtract to 2. So these factors of 15, if you subtract them, you get 2. So these are the numbers. That's my P and Q. So I'm going to do X, and I don't put in signs yet. So here's the way I do my signs. I go back to my rules of adding and subtracting positive and negative numbers to get a sum. So a positive 5 plus a negative 3, right? If you did positive 5 plus negative 3, or negative 5 plus positive 3, or if you did negative 5 plus negative 3, and negative 5 plus, let's see, did I get them all? So plus, minus, minus, plus, minus, minus, and I got to do plus, plus. Plus, plus. So the rules for adding positive and negative numbers, if the signs are both the same, you add the numbers. So 5 plus 3 is 8, and then you keep the signs. So that would be negative 8. Right? And then if the signs are different, you're going to subtract the numbers. 5 minus 3 is 2. 5 minus 3 is 2. And you take the sign of the larger absolute value add-in, basically. So the 5's larger than 3, so I take the sign of 5, so I get plus, and then 5 here is negative, so this would be negative. Right? So those are the rules. So if we're going back to this idea up here, when I'm adding these numbers, I want to get a positive 2. So the bigger number, the 5, gets the positive. And then I go to the rules about multiplying. If I'm multiplying, positive 5 times negative 3, negative 5 times positive 3. If the signs are different, so we got negative, negative, positive, positive. So when you're multiplying positive and negative numbers, you just ignore the signs. 5 times 3 is 15. So they're all 15. And then if the signs are different, the answer is negative. If the signs are the same, so these are different, so it's negative. These are the same, so it's positive. So those are positive. Okay? So remember, the C is going to be the product. P times Q is C. So the way I'm going to get a negative 15 is one of these two have to be negative. So if the bigger one was positive, then the opposite one will be negative. Okay, and then that will be my answer. And then if I want to check, oops, I want to check, you can just FOIL it out. So x times x is x squared. X times 5 is 5x. Negative 3 times x is negative 3x. Negative 3 times 5 is negative 15. And you can see positive 5 and negative 3 make positive 2x. And then I got minus 15. And that's the original problem. Okay? All right, let's try one more for good measure. So we're going to factor x squared minus 6x minus 16. Okay? So again, I'm looking for factors of 16. So this is the way I would do it. I want factors of 16. This is going to tell me to add or subtract, and that's to what? And again, I'm ignoring the sign for the moment. So I want factors of 16. So find factors of 16 that subtract to 6. So 16, so 1 and 16, and remember the square root of 16 is 4, so I just have to go to 4. So 1, 2, 3, 4. 16 divided by 2 is 8. 16 divided by 3 is a decimal number. 16 divided by 4 is 4. And now I want to do the difference, subtract. So 16 minus 1 is 15. 8 minus 2 is 6. 4 minus 4 is 0. So I want factors of 16 that subtract to 6. So see how that's the one I want. So those are my factors, 8 and 2, or 2 and 8, doesn't matter. The order doesn't matter. I can write 2 and 8, 8 and 2, doesn't matter. Right? Either one, same answer. What's important is the sign. So again, this sign goes to the bigger factor, bigger absolute value factor. So 6 is going to the 8 because 8's bigger than 2. So again, it doesn't matter where you put the 8 and 2, but 8 gets the negative because it's the bigger one. And then to get a negative 16, these signs have to be different. So that has to be positive. Let's do one more. Let's do x squared minus 9x plus, let's say, 18. So I want factors of 18. Let me try that again. Factors of 18 that add to 9. So factors of 18 add, so we're finding factors that add to 9. Okay, so let's start with our 18. 1 and 18. Again, if it's the first number that pops in your head, then you're done. You don't have to do anything else. But if you get stuck, do this, right? And you can use a calculator. 18 divided by 1 is 18. 18 divided by 2 is 9. Square root of 18 is like 4 point something something. So we can chop off all that. So we just have to go to 4. So 18 divided by 3 is 6. 18 divided by 4 is a decimal number. So we throw that one out. Now we're going to add. So 1 plus 18 is 19. So this is our sum. We're adding. Okay, 1 plus 18 is 19. 2 plus 9 is 11. 3 plus 6 is 9. That's the one we want. So it's 3 and 6. So x3, x6. Now I put in my signs. Remember, when I'm adding this, the larger factor will get the sign for the sum. So if the sum's -9, 6 has to be negative. Now when I'm multiplying to get a positive, I need both these signs to be the same as each other. So they're both going to be negative. A negative times a negative makes a positive. -3 plus -6, signs are the same. I add, that's why I'm adding. 3 plus 6 is 9, and I keep the sign, so it's -9. Okay? So if you wanted to check it, again, you just do the FOIL. So you get x squared minus 6x minus 3x. -3 times -6 is positive 18. Combine like terms, that's -9x. That checks. Okay, factor by grouping is the next learning objective. So to factor a trinomial in the form of ax squared plus bx plus c by grouping, we find two numbers with the product of ac and a sum of b. We use these two numbers to divide the x term into the sum of the two terms and factor each portion of the expression separately, then factor out the GCF of the entire expression. All right, let's look at example 3. So example 3, and then we'll go through this process. 5x squared, so it's factor. 5x squared plus 7x minus 6. All right, so we want to find the factors of AC. So 5 times... Now, I'm going to do what I did with the other one. I'm not going to worry about the negative. I'm just going to do 5 times 6 is 30. Now I'm going to do all my factor pairs of 30. So 1 and 30, 2 and 15. And remember, you just have to go down to the square root of 30, which is like 5 point something. So we just have to go down to 5. All right, you can actually calculate it, but 5 times 5 is 25. 6 times 6 is 36. 36 is bigger than that, so it's going to be 5 point something. Right? So 30 divided by 3 is 10. 30 divided by 4 is a decimal. 30 divided by 5 is 6. And now, just like we did in the other one, the sign of the last number, if it's negative, you're going to subtract these. So I'm going to get, I'm going to subtract. I'm going to get 29. 15 minus 2 is 13. 10 minus 3 is 7. And notice how they go in order. The biggest is on top and the smallest. So that would, if you're factoring something with a really big number, you can kind of tell if this number was too big, this one's too small, then there's nothing going to work, right? So if this was an 8, we wouldn't be able to factor it. 6 minus 5 is 1. So we want factors that add to 7, so that's this one. So 3 and 10. Okay. So 3 and 10, that's our P and Q. Now, as far as the signs, we're going to do the same thing. The bigger one's going to get a positive, and if this is negative for the product, so the bigger one's going to be positive, and then the other one would be negative. And we're going to rewrite this expression with the P and the Q. So it's going to be 5x squared. We have the 3x and the 10x, and then the -6. Now the signs, the bigger factor, the 10 is going to get the plus. And on the product, see the product was negative 30. To get a negative 30, these signs have to be opposites. That'd be negative. Okay. Now we're going to factor this as two separate groups. So you're going to look at the first group. So this is where we call it grouping. We're going to put, basically you're putting parentheses around the first two and parentheses around the last two. So what divides out of these two terms? So you look at the numbers first, 5 and 3, nothing. And then they both have an x in common. So you can take an x out. You're going to divide out the x. So that's 5x minus 3. Now you ignore the first group, look at the second group. What divides out of 10 and 6? Well, just 2. And then 10 divided by 2 is 5. And then you have the x. 6 divided by 2 is 3. And it's negative 3. Now your goal is, you think of this parenthesis, think of it as one number per minute. So I always tell my students, like, it's just like if it's x times w, think of that as one number. 2 times w. And you can see they have a w in common. So when you factor out the w, you're left with x plus 2. Well, it's not w, it's the 5x minus 3. So you're going to write the 5x minus 3. Right, this is 5x minus 3, 5x minus 3. Okay, so again, it's not the w, so I'm factoring out the parenthesis. Now the thing is, it has to match exactly 5x minus 3, 5x minus 3. So you can again think of that as one number, and you're factoring that number out, 5x minus 3. And then what's left over is the x plus the 2. All right, and that's how you factor by grouping. All right, let's look at one more example. Factor by grouping. So if we have 2b squared minus 25b minus 247. Okay, so we're going to do 2 times 247. So that would be what? 494. Now I'm going to, let's see, 494. Okay, use a calculator. 494 is 22.2. So I'm going to stop at 22. So 1, 2, 3, 4, 5. So this is 494. 6, 7. Let's see if 7 goes in there. No. Okay, so I can just keep trying until I find something that divides. So 494 divided by 2. It's 247. Duh, because it was right there. And 3, let's see, 8, 17. 3 is not going to work. You can try it, but three. No. 4. That won't work. That's a decimal. Then I'm going to try 5. 5 doesn't work. 6 doesn't work. 7 doesn't work. 8 doesn't work. 9 doesn't work. 10 won't work. 11. 12. There's some rules, shortcuts, but I'm not going to go over those right yet. Okay, 13 works. 13 and 38. 13 and 38. And you can see that subtracts to 25. So that's the one we want. So we're going to rewrite this as 2b squared. Okay, let me do the signs in a minute. So let me get rid of that. So I'm going to do 13b, 38b, and then minus 247. The bigger one gets the minus, and for the product to be negative, they have to be opposite signs. Now I'm going to factor out of this one just a b, so 2b plus 13, and then rule of thumb, if the first term in the second group's negative, you're going to factor out a negative, and we should get this exact thing. So I'm just going to guess that I'm going to take out a 19. So let me just double check that 19 goes into 247. So 247 divided by 19 is 13, which is what it should be, right? Because we want to match that parenthesis. And then we're taking negative, so negative, negative make positive. And then you can see the parentheses match. So you get 2b plus 13. And then what's left over is the b minus 19. And if you want to double check it, you FOIL 2b squared minus 38 plus 13, so that's right there. And 13 times 19 is 247, right? And it checks. So that's your answer. And this was number, I think I just told you a second ago. I forgot. It was number 18 in the exercise set. All right, on to the next learning objective. Factor a perfect square trinomial. Okay, so a perfect square trinomial can be written as a square of a binomial. So basically, we did this in the last section where if we FOILed this out, we end up with this perfect square trinomial. I think we had an x there, but same thing. So we're just going to factoring is reverse. So if we have a perfect square trinomial, we can write it in its factored form of a square, whatever that binomial was. So here's the process. So if you notice that the first term and last term are perfect squares, then you confirm that the middle term, or check that the middle term is twice the product of whatever a and b are, which are going to be the square roots of the perfect squares. And then if it is, then you can do the shortcut. You don't have to do any of those factoring techniques that we discussed before. Just it's going to be the perfect square of the binomial. So let's look at example 4. I'm just going to write it down. Factor the trinomial 25x squared plus 20x plus 4. So if you notice that this is a perfect square, 4 is a perfect square. This is 5x squared, and then this is 2 squared. So the a would be the 5x and the b would be 2. Now we want to check if it fits this pattern. Is 20 is 20x equal to twice AB. So remember, this is the A, so twice AB. So is 2 times 5x times 2, let's say 2, 10, 20x. And the answer is yes. If it does, then it fits the pattern, and then you know that this is just going to be 5x plus 2, so it's a plus b squared. And then you don't have to do any factoring techniques other than that. So you just recognize, oh, that's a perfect square trinomial. Fits this pattern, right? You just have to check that middle term, right? This is the key right here. Okay, moving on to factor a difference of squares. All right, this one shortcut comes up a lot, and it's basically you'll learn to love it like I do. hopefully. So different squares can be rewritten as two factors containing the same terms but opposite signs. So you got a sum and a difference. So if you have two squares and it's a difference, subtraction, so this is a difference of two squares. Sometimes we say two squares. Difference of squares. To factor it, you just square root both, and the middle term cancels, so you're going to get a plus and a minus. Right? So we factor it as that. All right, let's look at example 5. It says factor 9x squared minus 25. So you have to recognize that, oh, that's a perfect square. See, it's 3x in parentheses squared. And that's a perfect square. 5 squared is 25. So it fits the pattern. We got a difference of two squares. And then you're just going to do the first term, the square root of the first term. So that's 3x. Square root of the last term, 5. We're going to write it twice. And it's going to be the product of the sum and the difference. Or just change the signs. One's plus, one's minus. And it's simple as that. And if you want to FOIL it out and check it, you'll see the middle terms cancel. And you just get 9x squared minus 25. All right, on to the next learning objective. Factor the sum and difference of cubes. Okay, sum and difference of cubes. We can factor the sum. See, we can factor the sum of two cubes. So we got a cubed plus b cubed. So it's a sum of two cubes. You can factor it as the product of a plus b. And then a squared minus ab plus b squared. And then the difference of two cubes is going to be identical. Look at a, b. This is plus, this is minus. So those signs, you keep that first sign is going to match the problem. So if it's a sum, it's plus. Difference, it's minus. And then these terms are identical, except that middle term is going to be the opposite of what we started with. So if it's plus, minus, minus, plus. So you can kind of think of this acronym as, or actually we just say keep, change, always positive. Oh, here's that. Here's the acronym. Now I remembered it. SOAP. So same, opposite. So same as the problem, opposite, and always. So the AW, always positive. Okay, so what you do is you're going to cube root these numbers. That's your A and B. You're going to multiply the two together to get the middle term. And then you're going to take this number squared for the first term. Actually, I'm doing that a little bit out of order. So I'm going to cube root the numbers. So AB. Then I'm going to do A squared. The middle term is going to be the product of A and B. And then the last term is just going to be the B squared. Okay, so let's look at an example. So example 6. So I'm going to cube these. So again, if I think of it as this is x cubed, 512 is what, 8? 8 times 8, 64 times 8 is 512. Okay, so it's 8 cubes. So you got to recognize cubes. Usually these numbers aren't going to be too big, right? 10 cubes 1,000. So if it's under 1,000, try 2, 3, 4, 5, 6, 7, 8, 9 until you get there. You'll start recognizing some of them. Okay, so A is going to be x and B is going to be 8. And so when I do this, I'm going to take x and 8. I'm going to square the first one, so x squared multiply them together, so that's 8x, and then square the last one. And then the signs, I'm going to do the SOAP. Same as the problem, opposite, always positive. And I'm done. And if you FOIL this out, you'll see that it works. That's a check. All right, let's move on to number 7. And that's going to be a difference of cubes. I'll squeeze it on here as well. Well, I'll do it on a new page. Okay, so I'm going to think of this as a perfect cube. So this is 8 is 2 times 2 times 2, so it's 2x cubed. And normally you don't write this down. And 125 is 5 times 5 times 5. So again, to factor this, I'm going to take the a and the b, so 2x and 5. Then I'm going to square the first one, so a squared, so 2x is 4x squared. Multiply these together, so that's 10x. And then square the last one. And you just memorize this pattern. Again, it's something that comes up a lot. So the sign, same as the SOAP, same as the problem, opposite, always positive. And again, if you multiply that out to check it, you would see that it works. That everything cancels out except that first term and last term. And you get the difference of the cubes. And on to our last learning objective, factor expressions using fractional or negative exponents. Expressions with fractional or negative exponents can be factored by pulling out a GCF. Look for the variable or exponent that is common to each term in the expression and pull out that variable or exponent raised to the lowest power. So these expressions follow the same factoring rules as those with integer exponents. So here's an example. 2x to the fourth plus 5x to the 3/4 can be factored by pulling out x to the 1/4. So see, they both have an x that's common, and 1/4 is smaller than 3/4. So you factor out the x 1/4, and then remember when you're dividing it out with the exponent rules, you're subtracting. So 1/4 minus 1/4 is 0, so the x goes away. 3/4 minus 1/4 is 2/4, which reduces to 1/2. So that's where that came from. All right, so on this one, you can see the x plus 2 is common to both of. So if we think of this as having two terms because of the plus sign, so think of this as one term, and then this one is one term. X plus 2, those are the same variable term. Just think of it as one number for a moment. Those are the same. And then I take the smaller of the exponents. So I'm going to factor out x plus 2 to the negative 1/3. And then I'm left with 3x. And then, now this one's a little tricky because when we subtract 2/3 minus a minus 1/3, so minus a minus becomes plus, so that would be equal to 2/3 plus 1/3, which is 3/3, which gets you 1. So that one's a little tricky. So that would be 4x plus 2 to the 1. And then this can be simplified further by, right, you can drop that 1 parenthesis and then distribute the 4. So x plus 2 to the negative 1/3, 3x plus, now I'm going to distribute the 4. Now if this was a square, right, you would have to square that first, but since it's 1, just ignore it. It goes away. 4x plus 8, and then you can combine these like terms. So x plus 2 to the negative 1/3, and then I get 7x plus 8. And that would be my final answer there. That one you don't really want to be able to check be more complicated for the check. So just hopefully you didn't make any mistakes. Just go back and verify you didn't make any. Okay, and that looks like the end of the section, so make sure to work on the exercises at the end of that section, get some practice with these, and I will see you next time.